Human activity detection is more crucial in a challenging environment. Humans cannot be in all places all the time to detect suspicious activities. Therefore, we need to make accurate predictions to find the action without human intervention using technology. Our project focuses on human activity detection in the dark, where the invisible nature of identifying humans or things both indoors and outdoors results in a challenging environment. Image recognition and video recognition are both powerful techniques for accurate detection, however, they also have some disadvantages. Video recognition is often considered to be complex compared to image recognition and needs a large amount of data and computational power to train. Existing studies on human action recognition are mainly focused on supervised learning, which relies heavily on labeled data. Based on research, we built a supervised learning model to predict human action recognition accurately. Data collection focused on obtaining video datasets to include both spatial and temporal variation. Otherwise, considering only a frame may result in a false prediction of running as walking or vice versa. The synthetic dataset did not show promising results. Considering these aspects, we used the arid action recognition in the dark dataset for our model training, which is the only night vision dataset focusing on human action, which includes 11 classes of prediction. In the initial dataset analysis, we found the varying brightness and luminance of the dataset and the noises present in the video. And we found that there are a limited number of classes, and the videos are only for some classes. This is a sample video taken from the arid dataset which describes walk motion. Based on the preliminary data analysis, we got an idea about the luminance, contrast, and the static background nature of the videos, and we did the pre-processing. Initially, we extracted the video sequence into 20 image frames and did clay, which is an advanced histogram equalization technique, and gamma correction to improve both contrast and luminance respectively. We needed both pre-processing techniques to improve the brightness and differentiate the background from the foreground. After that, we did open pose extraction as a pre-processing step based on a pre-trained model open pose to get key points or heat maps that identify human actions. Once the pre-processing is done, the data is passed as data loaders to the model. We followed two approaches to model training. The initial method was based on transfer learning. Transfer learning is a machine learning technique where a model developed for a particular task is reused as the starting point for a model on a second task. It is a popular approach in deep learning where pre-trained models are used as a starting point for computer vision and natural language processing tasks. Why transfer learning? Since we had only a limited amount of data with limited amount of classes and we had limited computational resources, we planned on using the pre-trained model for model training. Here we used the R2 plus 1D model, which is a pre-trained model on the Kinetics 400 class dataset. Then we did our model training to our specified dataset. But running for a few epochs didn't improve the accuracy in testing. Due to the limited amount of computational resources, we tried only 2 to 4 epochs. Therefore, we shifted our model training to an LRCN model. LRCN is a long-term convolutional network that includes both CNN and LSTM. CNN focuses on extracting information from the image frames and LSTM focuses on extracting information from sequence data. We built an LRCN from scratch as our approach. Model evaluation based on confusion matrix and top 1 and 5 accuracies. During inferencing, we found that LRCN outperformed ResNet models and got higher accuracies. We were able to increase our top 1 accuracy from 10% to 79% and the top 5 accuracy from 50% to 96%. After inference, we deployed our model in AWS server. This is a demonstration of post-processing and action detection of a human walking. We can see the detection of human action with the confidence of the prediction, and also we can view the open pose keypoint image showing the action. When doing the project, we encountered issues with computational power and issues related to limited dataset having data shift. But overall, we got the experience of a complete data science project. We believe that the importance of human action detection in dark environments is critical for ensuring public safety, security, and efficient emergency response. Leveraging data science approaches in this domain can significantly enhance our capabilities in this area. By harnessing advanced technologies and data-driven methodologies, we can develop robust human action detection systems that effectively operate in low-light or no-light conditions, providing real-time insights and actionable intelligence.